Something is wrong in the darkness between the stars. Not a glitch, not a malfunction. Something that every model, every calculation, every theory we have built over decades of space science simply cannot explain. And the only witness to it is a 47-year-old spacecraft the size of a small car, running on less power than a refrigerator light bulb, drifting alone more than 15 billion miles from home. Voyager 1 just sent something back, and the scientists reading its data are not celebrating. They are quiet. And in science, that kind of quiet is the loudest alarm there is. To understand why this matters so deeply, you have to understand what Voyager 1 actually is. It is not just a machine. It is the farthest reaching thing humanity has ever built. Launched on September 5th, 1977, it was never supposed to still be working. Its original mission was simple. Fly past Jupiter, fly past Saturn, collect photos and data, and drift into history. But Voyager 1 refused to stop. It kept going, past Neptune's orbit, past the Kuiper Belt, past the termination shock. And then, on August 25th, 2012, it did something no human-made object had ever done before. It crossed the Heliopause, the boundary where the sun's solar wind stops and true interstellar space begins. In that moment, Voyager 1 became humanity's first ambassador to the space between stars. For years after crossing that threshold, the data it sent back was strange but explainable. Particle counts, magnetic field readings, plasma density measurements, all unusual compared to what we see inside our solar system, but within the range of what physicists expected interstellar space to look like. Cold, thin, quiet, a near vacuum, populated by traces of charged particles and faint magnetic fields stretching across light years. Scientists were satisfied. They thought they understood what was out there. They were wrong. The first signal that something was different came through Voyager 1's plasma wave system, a pair of antenna rods stretching 10 meters behind the spacecraft like metal whiskers reaching into the dark. This instrument was designed to detect vibrations in the charged particles surrounding the probe, essentially to listen to the hum of interstellar space. For years, it picked up exactly what was expected, a faint, steady murmur of plasma, the quiet background noise of the interstellar medium. Scientists described it as holding your ear to the cosmos and hearing a whisper. That whisper was consistent, predictable, understood, and then it changed. Engineers monitoring the data stream from Voyager 1 detected something they had never seen before. The plasma wave readings suddenly showed a sharp, rhythmic pulsing, not a random burst of noise, not a spike from a solar event, a pattern, regular intervals, almost like a heartbeat, pulsing through the charged particles of deep interstellar space in a region that, according to every model we have, should be producing nothing of the sort. The plasma wave system had been listening for over a decade. It had never heard anything like this before. Scientists did not know what to call it. They still do not, but that was only the beginning, because the plasma anomaly was not the only thing Voyager 1 found. The magnetometer, the instrument measuring magnetic fields, began returning data that made physicists stop mid-sentence. Out in the interstellar medium, magnetic fields are expected to be weak and chaotic. The remnants of ancient stellar explosions stretched thin over millions of years and billions of miles. What Voyager 1 measured was something entirely different, a thin region of intensely ordered magnetic fields. Not chaotic, not random, structured, arranged with a precision that defies what we know about how interstellar space organizes itself naturally. The fields were more powerful than they should have been, and they were aligned in a pattern that made no physical sense given where the spacecraft was. There was nothing nearby that should have produced them. No star, no known nebula, no cataloged structure of any kind. And if there is a like and subscribe button on your screen, hit it right now. Because what comes next is the part that nobody is saying out loud. In late 2023, Voyager 1 went through a communications crisis that terrified mission scientists at NASA's Jet Propulsion Laboratory in California. The spacecraft began returning garbled data, scrambled telemetry that looked like noise as if the computers on board had simply forgotten how to talk. Engineers initially blamed aging hardware. At 46 years old, every transistor, every memory bank, every system on Voyager 1 was operating far beyond its design life. A chip failure seemed like the logical explanation. And when JPL engineers finally managed to patch the problem remotely, sending a software fix across 15 billion miles of space and waiting over 22 hours for a response, they breathed out and called it a victory. But here's the question that was quietly left on the table. The chip that failed was not the kind that degrades slowly. Its failure pattern did not match normal hardware deterioration. And when the spacecraft came back online in mid-2024 and all 4 instruments resumed transmitting science data, the anomalous readings were still there, waiting. The magnetic hump, as researchers formally named it, was first noticed around 2020. Voyager 1's magnetometer recorded an abrupt jump in magnetic field strength at approximately 149 astronomical units from the Sun, a distance so vast that even light takes over 20 hours to travel it. That jump should have faded. Previous anomalies of this type, all of them generated by surges of solar plasma slamming against the outer boundary of the heliosphere, had always returned to baseline after a few months. This one did not. It persisted. It kept going. The field remained elevated for nearly 2 years straight in a way that mission scientists could not fully reconcile with solar activity alone. A peer-reviewed study published in 2026 in the Astrophysical Journal traced this magnetic hump through the data all the way from 2020 into mid-2025, noting that the behavior deviated significantly from every previous event on record. The structure of what Voyager 1 was moving through was unlike anything documented before. And then there's the question of cosmic rays. Inside the heliosphere, the Sun's magnetic field acts as a shield, deflecting high-energy particles from the galaxy. Once Voyager 1 crossed into interstellar space, cosmic ray counts were expected to rise and then stabilize. Instead, data began showing something unusual, a dampening effect. Cosmic ray levels near Voyager's trajectory were being reduced in a pattern that some researchers described as shielding. Something ahead of or surrounding the spacecraft appeared to be absorbing or deflecting high-energy particles. The symmetry of this dampening field was described in one analysis as highly unnatural. The leading hypothesis proposed a massive magnetic anomaly, perhaps the remnant of a dead star or a dense interstellar cloud. But the problem with that explanation is the geometry. The field was too clean, too symmetrical. Nature, at these scales, does not typically produce perfectly ordered structures in empty space. NASA has responded with caution. The agency formed a dedicated team to study the anomalous readings, and for the first time in years, real-time monitoring of all Voyager 1. Transmissions was increased. Funding for deep space monitoring was quietly expanded. These are not the actions of an institution that thinks it is looking at normal background noise. These are the actions of an institution that knows something unexpected is there and does not yet have the language to describe it. In official statements, researchers have repeatedly emphasized the need for more data. They have stressed that natural explanations must be exhausted before anything else is considered. And that is exactly the right scientific approach. But science also demands honesty about the edges of what is known. And right now, the honest answer is that we do not fully know what Voyager 1 is moving through. The implications stretch in two directions. The first is purely physical. If there is a region of structured, ordered magnetic fields and dampened cosmic radiation in the very local interstellar medium that we did not know existed, then our entire model of the space surrounding our solar system needs revision. The heliosphere may be shaped and influenced by structures we have never mapped. The boundary between our solar system and interstellar space may be far more dynamic and architecturally complex than textbooks have ever shown. Future missions, including the Interstellar Mapping and Acceleration Probe, will need to account for the existence of regions that behave in ways our current physics does not cleanly predict. That alone would be a landmark finding. That alone would reshape decades of astrophysical modeling. But the second direction is the one that keeps certain researchers awake at night, because everything described, the rhythmic plasma pulsing, the structured magnetic fields, the symmetrical dampening of cosmic rays, the pattern that looks deliberate, all of it shares a property that is very difficult to explain away with known natural processes. It looks organized. Organization at cosmic scales, in the absence of an obvious natural source, is a question that serious scientists are not supposed to ask too loudly. But they are asking it quietly, in peer-reviewed language and careful qualifications and footnotes that use words like anomalous and unprecedented and unlike previously documented behavior. What those words are pointing at, just beyond the edge of what the data allows them to say directly, is the possibility that Voyager 1 has not stumbled into a random patch of unusual space. It may have crossed into something that was already there, something that, by the laws of physics as we understand them, should not exist. There is a concept in the search for extraterrestrial intelligence called the Great Filter. The idea that advanced civilizations either never arise or disappear before they can spread through the galaxy. One of the darker versions of this theory suggests that civilizations go quiet not because they cease to exist, but because they encounter something that changes them, something out there in the deep dark between stars. Voyager 1 was never supposed to find anything. It was a message in a bottle thrown into an ocean we assumed was empty. What if the ocean is not empty? What if something has been reading the bottle? These are not answers. They are questions raised by data. Voyager 1 is still transmitting, its signal growing fainter every year as its plutonium power source slowly decays. Within the next decade, it will fall silent forever. But right now it is still out there, still moving, still listening with those fragile metal whiskers stretched into the dark. And whatever it is moving through, it is sending the readings back, one 22-hour delay at a time, to a species that launched it almost 50 years ago, and is only now beginning to realize that what lies beyond our solar system may be the greatest mystery we have ever failed to prepare for. The universe is not empty. Voyager 1 is proving that, and the question of what exactly fills it, what organizes it, what shapes it, what has always been there waiting, may be the most important question our civilization has ever stumbled into asking. Hit like and subscribe if this is the kind of question you want to keep asking, because Voyager 1 is not done yet, and neither are we. Voyager 1 crossed the Heliopause carrying a golden record, a disc etched with greetings in 55 languages, music from Bach and Blind Willie Johnson, the sound of surf and wind, and a mother's first words to her child. It was humanity's best attempt to introduce itself to the unknown. At the time, most scientists treated the golden record as a symbolic gesture, a romantic idea rather than a practical one, because the assumption was always that interstellar space was vast and empty and cold, that the odds of anything ever finding that record were so astronomically small as to be essentially zero. That assumption shaped everything, how we designed the probe, how we interpreted its data, how we categorized its readings. We sent a message into what we assumed was silence, but the data coming back now is beginning to suggest that the silence was never silence at all. It was something else, something patient, something that was there long before we were. The very local interstellar medium, the scientific term for the region immediately surrounding our solar system, has turned out to be far more active than expected. Turbulence, density fluctuations, magnetic structures that shift and evolve. A paper published in Nature Astronomy described persistent plasma wave emissions detected by Voyager 1 from 2017 onwards, a continuous narrowband signal that enabled scientists to measure interstellar plasma density across 10 astronomical units of space with unprecedented detail. What they found was a medium in constant motion, rippling with fluctuations driven by sources we have not fully identified. Some of those fluctuations trace back to solar shock waves reaching far beyond the heliopause. But others do not. Others have no clear origin at medium around Voyager 1 in patterns that the spacecraft's instruments register, but that our models cannot yet fully account for. This is the frontier of human knowledge in real time, not a historical discovery wrapped in comfortable distance and retrospective clarity. Something happening right now with instruments designed in the 1970s, transmitting data across a distance that makes the entire history of human civilization look like a footstep. Every reading that comes back from Voyager 1 is information that no living thing on Earth has ever had access to before. Every anomaly is genuinely new, and the anomalies are piling up. The magnetic hump that would not fade, the rhythmic plasma pulses, the structured fields, the dampened cosmic rays. Each one individually might be explained away. Together, they form a picture that the scientific community is still assembling in real time, choosing its words carefully, aware that whatever conclusion eventually emerges from this data will carry the weight of everything humanity believes about its place in the universe. We sent Voyager 1 out as a beginning, as an opening move in a conversation we assumed would never receive a reply. What it is finding out there in the dark may be evidence that the universe has always been more structured, more complex, and more aware of its own contents than we ever dared to imagine. That is not a comfortable thought, but it may be a true one. And right now, on the edge of everything we know, a 47-year-old spacecraft built by human hands is doing what it was always meant to do. It is looking, it is listening, and it is sending the answers home.